Papam.
Welcome back to our YouTube channel. We want to look at how to find an angle between two vectors. Again, angle between two vectors. Using cross product method. Cross product method. So in this case, we are going when we are given two vectors, say vector A, which is A1 I plus A2 J plus A3 K, and another vector B, which is B1 I plus B2 J plus B3 K, then we can find the angle between these two vectors A and B using the formula A cross B. Magnitude must be the same as A magnitude B magnitude sine theta, where theta is the angle between the two vectors. So if you want to find the angle between any two vectors, that is vector A and B, then the formula that we are going to use to find the angle between the two vectors is A cross B. Magnitude must be the same as A magnitude B magnitude sine theta. And in our previous videos, we said that for us to find A cross B, that is the cross product between two vectors, is always given by the determinant of a 3 by 3 matrix, that is vector I, J, K. Then the second row is filled by the elements of A, but the element of A along I in A1, along J in A2, along K in A3. And then the third row is filled by the elements of B. The elements of B along I is B1, along J is B2, and along K is B3. And the determinant of this 3 by 3 matrix is always given by the top row. It's given row signs given positive, negative, and then positive. So that will give us the cross product between two vectors. Once we get the cross product between the two vectors, we are going to get now its magnitude later. Then finally, we can also get the magnitude of a vector. Magnitude of vector A, as we said, magnitude of vector A is given by the determinant, is given by the square root of the square root of elements of A along I, which is A1, you square, you take A2, you square, then A3 square, you add all of them, then you get the square root. Similarly, B magnitude can also be given by square root of B1 square plus B2 square plus B3 square. Then once we get all the three components, once we get A cross B, we get its magnitude, it will give us A cross B magnitude. A magnitude will be given by this expression, B magnitude will be given by this expression. Once we find them, then we can use those three components to find the angle between the two vectors using the above formula. So in this case, I want us to look at a relevant example of how to find the angle between these two vectors. So let's consider two vectors. Vector A, which is given by I plus 4J minus 2K. And vector B, which is given by 2I minus J plus 3K. Then we are told to find the angle between vector A and B using the cross product method. Find the angle between vector A and B using the cross product method. So as we said earlier, we said that under solution, the cross product, we need to get the cross product between two vectors. Then after getting them, we get their magnitude. And this one should be the same as A magnitude multiplied by B magnitude sine theta, where theta is the angle, is the required angle. Where theta is the required angle. So we want to determine A cross B, then we get the magnitude, then we equate it to A magnitude, B magnitude sine theta. So let's start with getting A cross B. And we said that for us to get A cross B, it is always given by the determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix, which the first row in this 3 by 3 matrix, this one must be a 3 by 3 matrix. In the first row, it is always the elements I, J, K. The second row of this determinant is given by the elements of A. The element of A along I is 1. That is 1I. So the element along I is 1. Then the element of A along J is 4. Is 4. Along J is 4. Then the element of A along K is -2. So we have 1 is along I, 4 along J, and then -2 along K. Then the element of A along the element of B will now, the elements of B will be used to fill the third row. So the element of B along I is given by 2, along J is given by -1, and finally along K is given by +3. And then we can now solve the determinant of this 3 by 3 matrix, which we know, as we have said in our previous videos, we use the top row, we give them sign, that is positive, negative, and then positive. So we're going to say positive I, which is I. Then when we close the row and the column where I is, the row, when we close this row and the column, these elements that will remain, we are going to get their determinant, that is -4, -2, -1, and 3. That is going to remain. Then we -j, so it will be -j again. Then we close the row and the column where j is. So when you close the row and the column where j is, we are going to begin with 1, -2, 2, 3. Then finally plus k, plus k. Finally again we close the row and the column where k is. When you close the row where k is and the column, we are going to remain with these 4 elements. That is 1, 4, 2, -1. Then we get their determinant. So we can now solve, this is now the determinant of a 2 by 2 matrix, which we are going to solve. This is I. Then the determinant of a 2 by 2 matrix is given by the product of the elements along the primary diagonal. That is 4 times 3 will give us 12. Then we minus the product of the elements along the second diagonal. That is -1 and -2. That will give us 2. Then we minus j into the elements along the primary diagonal. 1 times 3 will be 3. We minus the element along the second diagonal. That is 2 times -2. That will give us -4. Then finally plus k into primary diagonal will give us -1. Second diagonal will give us 8. So finally the cross product between A and B will be found to be 12 minus 2 is 10. So it will be 10i. 3 minus -4 will be 7. 7 as that will give us -7j. And finally -1 you minus 8 will give you -9. But -9k. So that is now the first step we have done, how to get the cross product between two vectors. Once we have the cross product between the two vectors, the formula wants us to get the magnitude. So the magnitude of our answer now, magnitude of A cross B can now be obtained by square root of the element of A cross B along I, the 10, so this is going to be 10 squared, you add to the element of A cross B along J, which is -7 squared, then you add to the element of A cross B along K, which is -9 u squared. So this will give us the square root of 10 squared is 100, 7 squared is 49, 9 squared is 81. This will give us square root of 230. So A cross B magnitude is root of 230. Is root of 230. Which, if we put to 4 decimal places, we are going to find that root of 230 is 15.1658. So this will give us A cross B magnitude. So that one is going to be A cross B magnitude. So the only thing that is remaining in the formula is to find A magnitude, B magnitude, and then sine theta. So similarly, we can now get A magnitude, vector A magnitude, which we said is going to be the square root of the element of A along I is 1 square. We add the element of A along J is 4 square. Then the element of B of A along K, which is negative 2 square. This is going to give us square root of 1 plus 16 plus 4, which will give us root of 21, which in 4 decimal places will give us 4.5826. Similarly, magnitude of B, vector B, will be root of element of B along I with 2 squared plus along J is negative 1 squared plus along K is 3 squared. This will give us root of 4 plus 1 plus 9, which will give us root of 14, which to 4 decimal places will give us 3.7417. So that will be A magnitude and B magnitude. So according to the formula, for us to get the angle, we have A cross B magnitude, A magnitude, and then B magnitude. We can now substitute these results which we have found in this formula for us to get the angle between those two vectors. So we can substitute them in the formula as shown below. So A cross B magnitude, we have it as 15. So A cross B magnitude will be 15.1658, should be the same as, should be equal to A magnitude, which we have as 4.5826 multiplied by B magnitude, but B magnitude is 3.7417, then sine theta. If you multiply these two, we get 15.1658 should be the same as, multiplication of these two will give us 17.1467142 sine theta. And because we want the angle, we can divide both sides of the equation by 17.14671442. Both sides of the equation should be divided by that. 14671442. This one will cancel this, and we are going to remain with sine theta. Then this side will give us 0.8844726534. So that is now what we are going to find as sine theta. So for us to get theta, which is the angle between the two vectors, we simply find the sine inverse of the right side, the left hand side of the equation, of what we have on the left hand side of the equation, that is 0.8844726534. And they will give us the angle to be 62.1867 degrees. This is to 4 decimal places. So that gives the entire process of finding the angle between two vectors using the cross product